Understanding the challenges inherent in dealing with artificial intelligence and large language models is important in navigating the future technological landscape. Categorizing these challenges as either individual AI fallacies of flawed reasoning patterns or flawed datasets leading to incorrect conclusions will make it easier to troubleshoot both the AI systems and the issues that arise from humans interacting with them. The reason AI problems cannot be solved in the same way as human problems is attributed to the evolving nature of AI-human interactions. Unlike traditional AIs, which were simpler and produced mainly numerical or measurable results, contemporary AI, especially language models, introduces new and more complex failure modes. These models can actively deceive users, making it imperative to approach problem solving in the AI domain with a nuanced understanding of these unique challenges. The comparison underscores that strategies effective in solving human problems may not directly translate to resolving the intricacies posed by AI-related issues. Avoiding assumptions about AI. Don't make assumptions about how the AI works or is trained. You'll certainly be wrong. Just like people used to believe that bad air causes diseases, don't assume things you don't know or can't prove. Debugging an AI is not the same as operating it. Symptoms and root cause differ widely. There are many failure modes in AI where a bug that's introduced, whether in code or in the data, is only diagnosable much farther in the system. As long as the data doesn't break the code, you're likely to have no idea where it comes from. A simple example: if you introduce a bug that assigns the value 0 to a feature in your input dataset, your accuracy will drop, but nothing will actually fail. Your model has less information, but it's only going to be visible at the very end of your pipeline. Here, the symptom and root cause are on opposite ends of the pipeline. Don't personify your model. Don't give your model a personality of its own. This will inevitably lead you to assume something about the model's behavior which is not true. You are likely to attempt to explain the model's behavior in human terms, which is almost never how the AI would actually come to the prediction. Every model has a shelf life. You cannot expect a model to perform as well as it used to if you never retrain it. This idea is called drift. Your input data will change, your business objective will change, your data may become unbalanced. Extrapolation is hard. Machine learning models are usually randomly initialized. This means that any area where they did not have any examples to learn from will most likely devolve into random noise, pretty close to the most extreme training example. The model simply was never penalized or rewarded to perform predictions outside its training space. With the nonlinear nature of most machine learning models, you'll find that error grows extremely quickly outside your training space. Don't confound qualitative and quantitative errors. When an AI fails, it looks nothing like when a human fails. There is basically no telling if a task that's easy for you will translate into something easy for an AI. They deal very easily in numbers. We deal in experiences. You may think your AI is dumb when you analyze each and every mistake qualitatively, but most likely it's succeeding better than you could ever quantitatively. It's up to you to decide if that fits your requirements. The AI does exactly what you've trained it to do. If your model is performing very well in training but poorly at prediction time, it may be that your training and prediction objectives are misaligned. The AI won't know what you mean if you've only given it vague guidelines or objectives. Bias in your data means bias in your AI. You're probably not going to notice this at first, but it'll show up when you dig into your results. Some category may have a much higher error, and you'll realize that your model replicated the bias present in your data. You'll need to balance how much of each category is present in your data. When AIs see some type of data more often, they'll be biased towards that data because they're being trained as if this data is more important. Don't tamper with inputs or outputs. It's okay to serve a default prediction when you know the prediction is wrong. But it's never going to lead to good outcomes if you start modifying inputs or outputs, especially inputs. It's almost certain your model has no idea what you're talking about when you change inputs, because it only expects to see inputs it's already seen together. You surely will not be able to construct inputs yourself that make sense to the model. If tampering with inputs is a felony, tampering with outputs is more of a misdemeanor. You're likely to mislead your users, and if you know how to modify the outputs in the first place, then probably your application can be a set of business rules and not an AI. Chaining more than 3 models is very dangerous. It simply increases the number of failure points so much. If any of them stop working, you're taking out the whole system. Generally speaking, if 2 individual neural networks can learn a single task together, a single larger model will learn the same task just as easily. Chaining models necessitates that you define the objectives of each model very well, and then you're stuck with that interpretation of your problem. A single model can choose how it uses all the information presented much better than you can. Error of chained models grows exponentially. Even if you have incredibly accurate models, let's say 95% accurate each, and you combine 3 of them together, you'll have an accuracy of at the very best 0.95 equal sign 0.86. That's pretty much the best possible scenario. It's much more likely that even if in isolation each model has 95% accuracy, the usage of inaccurate data coming from another model will induce the other model into error by much more than 5%. What you may do in this scenario is use the subsequent models as calibrators. Instead of simply using the outputs from the previous model, the calibrator will understand the biases of the previous models and attempt to correct them. This necessitates that the earlier models be part of the training process of the next models. This introduces complexity but lowers error. If you're using chained models, make sure that the contract between your models is very well documented and enforceable. When you evolve one of the models, it has to continue respecting the contract with other models. Otherwise, the data will not mean anything anymore to the other models. If your first model outputs a dollar value and you start using euros as well without labeling them as such, your next model will not know that it now has to deal with several currencies. Even if you change a seemingly inconsequential detail of your contract, you need to make sure that everything still works as expected. You're the only one responsible for your AI. Your AI won't police itself. There isn't yet a legal defense of the AI did it, therefore I'm absolved. You need to take ownership of your predictions and recommendations. If you're replacing 10 people with an AI, you're taking upon yourself the accountability of the predictions it would normally take 10 people to sanitize and verify. Using AI will not and should not absolve you from your professional and legal obligations. Non-technical people sometimes think that an AI operates as a human that can react as soon as it sees new information. This is not the case unless you are doing online learning, which is rare. AIs generally have 2 modes, training and inference. If new data shows up, even if the model has done inference on it, if it did not have the opportunity to be trained on it, it will always repeat the original prediction. Only when the data makes it to the training window, and that data gets consumed by the model at training time, can the model adjust its predictions. You should never let your AI make decisions unsupervised. You should always set bounds for reasonably expected outcomes that you know can't damage your business objective. Your users may not even know they're dealing with AI predictions and recommendations. It's much better for the user's safety and trust to refuse to provide a prediction rather than to suggest crazy outcomes. Here's where you can start with. Build a limit for impossible outcomes, then build a limit for unsound outcomes. You should never rely on a single metric about overall performance. You need to track that each component in your pipeline is still working fine. Sometimes, major errors get obfuscated in an aggregate dataset, and you'll find out you are serving wrong predictions for months. Hopefully, this can help you navigate operating an AI if you are getting ready to do so. We're going to go from thousands of people operating AIs to millions in probably a few years. Be sure to stay on top of your AI operation knowledge in this ever-changing technological landscape.